Hello and welcome to episode 15. It's a strange one today. I've been doing some research on fair use copyright laws and it has made nothing clearer. I have absolutely no idea if what I'm about to do is okay, if I'm about to lose a podcast or whatever, but I am going to do an episode on Yellowstone, the supervolcano, and I'm going to take a reading out of this book, which is my absolute favorite book. It's got an incredible amount of information in here and cool pictures, which I like. So I hope that's enough right there for this to be fair use. I'm not going to read the whole book. I'm just going to read a couple pages out of this chapter. Um, and bear with me. I'm not a professional reader. I might run out of breath and all that, but without any further ado, Chapter 15 by Bill Bryson, Dangerous Beauty. In the 1960s, while studying the volcanic history of Yellowstone National Park, Bob Christensen of the United States Geological Survey became puzzled about something that oddly had not troubled anyone before. He couldn't find the park's volcano. It had been known for a long time that Yellowstone was a volcano in nature. That's what accounted for all of its geysers and other steamy features. And one thing about volcanoes is that they're generally pretty conspicuous. But Christensen couldn't find the Yellowstone volcano anywhere. In particular, what he couldn't find was a structure known as a caldera. Most of us, when we think of volcanoes, think of the classic cone shape of a Fuji or a Kilimanjaro, which is created when erupting magma accumulates in a symmetrical mound. There's a picture. I think that's Mount Fuji. That's what they mean. Like, the lava comes out and makes the mountain. These can form remarkably quickly. In 1943, at Paracutin, I don't know how to pronounce that, in Mexico, a farmer was startled to see smoke rising from a patch on his land. In 1 week, he was the bemused owner of a cone 152 meters high. Within 2 years, it had topped out at almost 430 meters and was more than 800 meters across. Although there are some 10,000 of these intrusively visible volcanoes on Earth, all but a few hundred of them are extinct. Damn it, I read that wrong again. Altogether, there are some 10,000 of these, but all but a few hundred of them are extinct. But there is a second, less celebrated type of volcano that doesn't involve mountain building. These are volcanoes so explosive that they burst open in a single explosive rupture, leaving behind a vast, subsided pit, the caldera, from a Latin word for cauldron. Yellowstone was obviously of this second type, but Christensen couldn't find the caldera anywhere. By coincidence, just at this time, NASA decided to test some new high-altitude cameras by taking photographs of Yellowstone, copies of which a thoughtful official passed on to the park authorities on the assumption that they might make a nice display photo for one of the visitor centers. As soon as Christensen saw the photos, he realized why he had failed to spot the caldera. Virtually the whole park, 9,000 square kilometers, was caldera. The explosion had left a crater nearly 65 kilometers across, much too huge to be perceived from anywhere at ground level. At some point in the past, Yellowstone must have blown up with a violence far beyond the scale of anything known to humans. Yellowstone, it turns out, is a supervolcano. It sits on top of an enormous hotspot, a reservoir of molten rock that begins at least 200 kilometers down in the earth and rises to near the surface, forming what is known as it's got a cool picture of lava, forming what is known as a superplume. The heat from the hotspot is what powers all of Yellowstone's vents, geysers, hot springs, and popping mud pots. Beneath the surface is a magma chamber that is about 72 kilometers across, roughly the same dimensions as the park, and about 13 kilometers thick at its thickest point. Imagine a pile of dynamite about the size of an English county and reaching 13 kilometers into the sky, to about the height of the highest clouds, and you have some idea of what visitors to Yellowstone are walking around on top of. The pressure that such a pool of magma exerts on the crust above has lifted Yellowstone and its surrounding territory about half a kilometer higher than it would otherwise be. If it blew, the cataclysm is pretty well beyond imagining. According to Professor Bill McGuire of University College London, you wouldn't be able to get within 1,000 kilometers of it while it was erupting. The consequences that followed would be even worse. Superplumes of the type on which Yellowstone sits are rather like martini glasses, thin on the way up and then blooming out as they near the surface to create vast bowls of unstable magma. Some of these bowls can be up to 1,900 kilometers across. According to current theories, they don't always erupt explosively, but sometimes burst forth in a vast, constant pouring out of flooding molten rock. I fucked that sentence up so bad. But sometimes burst forth in a vast, continuous outpouring, a flood of molten rock, as happened with the Deccan traps in India 65 million years ago. These covered an area of over 500,000 square kilometers and probably contributed to the demise of the dinosaurs. They certainly didn't help. With their noxious outpourings of gas, superplumes may also be responsible for the rifts that cause continents to break up. Such plumes are not all that rare. There are about 30 active ones on the Earth at the moment, and they are responsible for many of the world's best-known islands and island chains. Iceland, Hawaii, the Azores, Canaries, Galapagos archipelagos, Little Pitcairn in the middle of the South Pacific, and many others. But apart from Yellowstone, they're all oceanic. No one has the faintest idea how or why Yellowstone's ended up beneath a continental plate. Only two things are certain: that the crust at Yellowstone is thin, and that the world beneath it is hot. But whether the crust is thin because of the hot spot, or whether the hot spot is there because the crust is thin, is a matter of heated debate. The continental nature of the crust makes a huge difference to its eruptions. Whereas the other supervolcanoes tend to bubble away steadily in a comparatively benign fashion, Yellowstone blows explosively, and it doesn't happen often, but when it does, you want to stand well back. Since its first known eruption 16.5 million years ago, it has blown up about 100 times. But the most recent 3 eruptions are the ones that get written about. The last eruption was 1,000 times as big as that of Mount St. Helens. The one before that was 280 times as big, and the one before that was so big nobody knows how big it was. It was at least 2,500 times as big as St. Helens, but perhaps 8,000 times. We have absolutely nothing to compare it to. The biggest blast in recent times was that of Krakatoa in Indonesia in August 1883, which made a bang that reverberated around the world for 9 days and made water slosh as far away as the English Channel. But if you imagine the volume of ejected material from Krakatoa as being about the size of a golf ball, then that from the biggest of the Yellowstone blasts would be the size of a sphere you could just about hide behind. So a golf ball and then a ball that is as big as a person. And this is a picture of maybe Krakatoa, I'm not sure. On this scale, the Mount St. Helens eruption would be no more than a pea compared to Krakatoa, which was a golf ball. The Yellowstone eruption of 2 million years ago put out enough ash to bury New York State to a depth of 20 meters, or California to a depth of 6 meters. This was the ash that made Mike Voorhees fossil beds in eastern Nebraska. That's from a chapter before. The blast occurred in what is now Idaho, but over millions of years, at a rate of about 2.5 centimeters a year, the Earth's crust has traveled over it, so that today it is directly under northwest Wyoming. The hot spot itself stays in one place, like a propane torch aimed at the ceiling, but the ceiling moves. In its wake, it leaves the sort of rich volcanic plains that are ideal for growing potatoes, as Idaho's farmers long ago discovered. In another 2 million years, geologists like to joke, Yellowstone will be producing French fries for McDonald's, and the people of Billings, Montana we'll be stepping around geysers. The ash fall from the last Yellowstone eruption covered all or parts of 19 western states, plus parts of Canada and Mexico, nearly the entirety of the United States west of the Mississippi. This, bear in mind, is the breadbasket of America, an area that produces roughly half of the world's cereal crops. And ash, it is worth remembering, is not like a big snowfall that will melt in the spring. If you wanted to grow crops again, you would have to find some place to put all the ash. It took thousands of workers 8 months to clear 1.8 billion tons of debris from the 6.5 hectares of the World Trade Center site in New York. Imagine what it would take to clear Kansas. And that's not even to consider the climactic consequences. The last supervolcano eruption on Earth was at Toba in northern Sumatra, 74,000 years ago. No one knows quite how big it was, but it was a whopper. Greenland ice cores show that the Toba blast was followed by at least 6 years of volcanic winter, and goodness knows how many poor growing seasons after that. The event, it is thought, may have carried humans right to the brink of extinction, reducing the global population to no more than a few thousand individuals. That would mean that all modern humans arose from a very small population base, which would explain our lack of genetic diversity. At all events, there is some evidence to suggest that for the next 20,000 years, the total number of people on Earth was never more than a few thousand at any time. That is, needless to say, a long time to spend recovering from a single volcano. All this was hypothetically interesting until 1973, when an odd occurrence made it suddenly momentous. Water in Yellowstone Lake, in the heart of the park, began to run over the banks at the lake's southern end, flooding a meadow, while at the opposite end of the lake, the water mysteriously flowed away. Geologists did a hasty survey and discovered that the large area of the park had developed a bulge. This was lifting up one end of the lake and causing the water to run out at the other, as would happen if you lifted one side of a child's paddling pool. By 1984, the whole central region of the park, over 100 square kilometers, was more than a meter higher than it had been in 1924, when the park was last formally surveyed. Then, in 1985, the central part of the park subsided by 20 centimeters, about 8 inches. It now seems to be swelling again. And the reason I'm even doing this recording is because I was reading online that they have measured a swelling, so it's bulging up again. The geologist realized that only one thing could cause this: a restless magma chamber. Yellowstone wasn't the site of an ancient supervolcano. It was the site of an active one. It was also at about this time that they were able to work out that the cycle of Yellowstone's eruptions averages one massive explosion every 600,000 years. And the last one was 630,000 years ago. Yellowstone, it appears, is due. And I don't know if I'm biting off, trouble here if I keep going and reading, but I think that is enough information to make it extremely clear how dangerous the supervolcano under Yellowstone National Park is. Aside from the fact that it could just spew lava like a faucet, just rain lava, it could do that, but even if it doesn't do that, if it just goes boom one time, the ash in the air will make it dark. They were saying that other volcano made it dark for 6 years of volcano winter. So it's just constantly dark and cold. Sun doesn't come in. This one would be significantly bigger than that. So you got to think longer than 6 years before the next summer to grow food. I know for sure that if Yellowstone goes off, I'm dead. I don't know about you, but I am definitely dead. Thank you for listening. Hope it wasn't too unbearable.